Hello, I'm Gabe Cobb. You've seen me in such fine quality, epic chemistry educational videos as Gibbs free energy and entropy. What could go wrong? And enthalpy and entropy with temperature makes up free energy? What's up with that? Alright, today we're going to be looking at an equation dealing with delta G, taking into account the enthalpy, the delta H, the temperature of the reaction, as well as the total entropy of the reaction. And we have done an earlier video where we can go and calculate the delta G, the total delta G of a reaction based off of the delta G of the products and the delta G of the reactants. But that's another video. This is a different one. So let's get started. So we have a reaction, has a delta S of negative 100 joules per Kelvin times mole and a delta H of negative 80 kilojoules per mole at 200 C. Okay, calculate the delta G for the above reaction given this particular equation. Okay, well first we need to do a few things. This needs to be converted. We need to convert this to 80,000 joules. So we're going to do that right now. So there's 80,000 joules per mole, okay? And we are going to take away, now the temperature is 200 Celsius, but remember we work with Kelvin, so we have to change the Celsius to Kelvin. How do we do that? You add 273. So that's going to make a 473, okay, multiplied by, well in this case we have a delta S of negative 100. So this is what we have, and that's going to equal our delta G. Okay? So we give that, so basically what we're looking at here, ladies and gentlemen, we look at, sorry, that's a negative 80,000, okay? So you have negative 80,000, and we're going to subtract 47,300. Let me write that in there. Okay, so we have that. Now, being that its final answer is delta G. Okay, and remember, I'm sorry, this is a negative number, right? So, with that, when you have a negative and a negative, that becomes positive. So it's going to be negative 80,000 plus 47,300, which gives us a negative 32,700 joules per mole. Now, is this reaction spontaneous? That's the question. Remember, spontaneous has to do with, is the reaction going to proceed forward without any outside interference, any outside energy? If delta G is less than 0, then yep, the reaction is in fact going to be spontaneous. And guess what? Delta G is negative, the reaction is going to happen spontaneously. Alright, let's take a look at another one here. So we have another reaction, and this one has a delta S of plus 100 joules per Kelvin times moles. Ooh, a positive entropy. Guess what? That means there is more disorder, more chaos in our reaction. And a delta H of negative 80 kilojoules, so it's negative 80,000 joules per mole at 100 degrees Celsius, or 373 Kelvin. So that's what we've got going for us. Okay? So, here we go. We have here our delta G equals delta H minus T delta S. Alright, let's plug that in. So we have negative 80,000, okay, minus our temperature, okay, that's 373, multiplied by 100. It's a positive 100 this time. Okay, so that kind of changes things a little bit. So that's going to be negative 80,000 plus a negative 37,300. Okay, we have that. So then at the end of it, when we go and finish these calculations, it's going to, our delta G is going to equal negative 117,300 joules per mole. And that, ladies and gentlemen, is our final answer. Hey, is this particular reaction spontaneous or non-spontaneous? Well, remember, if delta G is less than 0, it's spontaneous. If delta G is greater than 0, it's non-spontaneous. You have to put in the outside effort to make the reaction happen. So, in this case here, this reaction is also spontaneous. Now, what would happen if our delta H, instead of giving off energy like it does, what if it was positive? Let's change that for a moment. If it was positive instead, then, well, you know what? Then you've got another situation, don't you? You have another situation where, in this case now, it's 80,000 plus a negative 37,300. Well, if we look at that, that's going to be 42,700, okay, joules per mole. And that is going to be a positive number. And guess what? In that case, with delta H being positive, which means it's absorbing the energy, that delta G is now going to be a positive number. It's non-spontaneous. So that means we have to put in the outside energy into it. Don't get caught up as far as predicting. You've got to go and plug in the numbers in order to make it work. All right. Ladies and gentlemen, that's it. I hope this video benefited you. If you were looking for the delta G of a reaction, meaning the delta G of products minus the delta G of the reactants, the summation of the, where delta G is the summation of the delta G products minus the summation of the delta G reactants, then you have to check out the other video dealing with calculations with delta G. Hey, until the next time, take care.